Show. Tucker, are you up? All right. Thanks, everybody. So we'll be in here for a little while longer for our next presentation, and then it'll be dinner in the Great Hall. So thanks for, I know it's been a super long and amazing, and your brains are probably like exploding kind of day. Your brains might explode a little bit more after this next presentation, and that's okay, because there's like so much to know and so much to learn. So thanks for all your great attention today, and for being present as we figure out how we're going to change the world, because that's what's happening. All right, Tucker, take it away.
Yes. So today I have the honor of introducing two speakers today. And I'll start with Gretchen Hooker. Gretchen is program manager at the Biomimicry Institute. Her work focuses on educational outreach. Projects she has led include the Ask Nature Resources Library, the Biomimicry Toolbox resource site, and the new Biomimicry Youth Design Challenge. Before joining the Institute, Gretchen was the founding director of the Office for Sustainability at Montana State University and worked as a designer, writer, and co-curator for many exhibits and publications. Gretchen is a certified biomimicry specialist and holds a master's degree in industrial design from the Rhode Island School of Design. We will also be joined by Dorna Schroeter. Dorna has been the coordinator of PNW BOCES Center for Environmental Education since 1982. This program serves some 36,000 students. She is a member of the Biomimicry Institute's international leadership team and is an advisor to their educators network. She teaches a biomimicry program for grades 5 through 12, runs teacher trainings, and has a written article about biomimicry for Green Teacher magazine. Since 2012, her focus has been to integrate education for sustainability into the K through 12 curriculum. Without further ado, please give a warm welcome to Gretchen Hooker and Dorna Schroeter.
Thank you so much. Is this the one is that picking up okay? No. I don't know if should I hold this thing? I'll lean in. No. Or talk louder. Anyway, thank you so much for having me. And I do want to just give a little, Dorna, will you stand up and wave? Dorna's going to be joining later in the program. We're going to do this session in 2 parts, actually. She'll be up here with me later. But first, I wanted to start with a bit of an overview on biomimicry. How many of you guys have heard of biomimicry before? Oh, I love seeing that many hands. That's great. So hopefully I'll have something new to share with you. I'm really excited about this topic because as a designer who's really passionate about nature, it was the perfect fit for me and my interests. I was always very interested in the natural world and almost pursued a degree in environmental studies, but as an artist at heart, design ended up sort of being the path that I followed, and coming into biomimicry was really sort of the perfect marriage of those interests. And even since I have learned more in biomimicry, it's even enriched and deepened my love for and value for nature, and so that's something I'm hoping to share with you today. And then at the latter half of the program, we're going to have a special guest, an animal visitor from the Wild Center, and we're going to do a little exercise, which will be sort of like trying on biomimicry goggles, and sort of an exercise in seeing seeing nature and the natural world through that lens. So make sure to stick around. Oh, and I want to make sure also to thank, it was Kelly Carter here who I met and learned about this incredible event. She was at the Green Schools Conference in Denver. So thank you so much for the invitation to be here. I've been super impressed with the campus and everything that's going on here. 10 years of mobilization of young folks like you. It's really inspiring. So. I know I don't need to tell you about climate change. That's why you're here. You've been hearing about it all day. But I do like this short, succinct list. And what I'm hoping I can share with you today is how learning from nature can start to help us with some of these problems. So why look to nature? Well, nature's a really great example of a sustainable world, right? Organisms and ecosystems have been evolving on this planet for something 3.8 billion years, and they've arrived at some pretty good strategies for living here without spoiling the proverbial nest, right? We like to think of it as basically 3.8 billion years of Earth-approved research and development. The organisms that are alive today have sort of figured out what works and what's going to last, right? All these organisms living together, creating conditions that are conducive to the continuation of life, right? You could think of it as sort of the first circular economy. I don't know if you guys are familiar with that word, if you heard of the circular economy or cradle-to-cradle design, the idea that our resources should flow in a circular path, that everything we make should be decomposable back into useful constituents and turned into new stuff. You know, that's an idea that comes from the natural world. Like, that's how the natural world works, right? So really, if we were going to put a definition to it, biomimicry is the practice of adapting nature's best lessons to the invention of more sustainable technologies for people. And it really signals sort of a key shift from harvesting or extracting products from nature to thinking about what we can learn from nature. And it starts with paying attention, right? Noticing what works in the natural world. So, for example, why are lotus leaves so clean? Lotus grow in muddy, marshy waters, and in the parts of the world where they grow, they're revered as a sacred plant because they are so clean. And the reason they're clean is because they have a microscopic roughness to their leaf surfaces, which make them very hydrophobic, which means they repel water. So what happens is the water beads up. It wants to stick to itself more than it wants to stick to the leaf. And so the slightest shift in orientation of that leaf, that water will just roll right off, and it'll take any dirt or other material that can adhere to water with it. And this idea has been incorporated into a more sustainable stain repellent fabric. So sort of the gold standard typical way of creating a stain repellent fabric is to coat it in fluorochemicals, which you might not be surprised to learn, don't have such a great track record for safety. This material isn't 100% free of those chemicals, but it uses far, far less, because instead of coating the entire surface of the fiber or of the fabric, it's using tiny nanoparticles of it on the fibers to create that same roughness that the lotus leaf has, so that it repels material. And in this image, you're looking at red wine, water, soy sauce, and I don't know what the green stuff is, all just beating up. It won't penetrate the fabric. We could ask, how do kelp survive life in the beating surf, right? So kelp, have leaf-like blades, and they're constantly being battered by waves. And yeah, of course, we see them washed up on the beach sometimes after big storms, but why aren't they shedding and losing these things all the time, right? Well, Jay Harmon is an innovator who grew up in Australia, and as a child, he was fascinated by that question too. And he noticed that it survives because instead of sort of violently flailing in the surf like the way a flag does in the wind, it actually changes its shape, and it sort of twists into a spiral, and the water just kind of flows through by it with much less turbulence. And he began to observe that feature of fluid flow in the natural world repeating in place after place. And he ended up developing a whole series of fluid handling devices that use this principle of spiral motion and pulling fluids instead of pushing them, that are radically more efficient. The sort of most widely used one is he calls it the Lily impeller. It's about 6 inches tall, but it can mix 100 million gallons of water with just the power of a couple light bulbs. These are used in large municipal storage tanks, which you need to keep the water circulating in these tanks because just the nature of sort of the fluid dynamics in there, they'll stratify or settle, and you'll get a layer of warmer water on top, which is more conducive to the growth of things you don't want in your water supply. And so to combat that, the water either needs to be mixed or they need to dump a whole lot more chemicals in it. But with just this tiny little device, you can keep that water moving. It stays a lot cleaner, it helps aerate it, and they can use far less chemicals. And it's dramatically more energy efficient as well. So that was a couple examples of sort of looking at the natural world and saying, hey, so what's going on there? We can also look at problems that we have in our world and say, well, what can nature teach us about solving this problem? How could we improve wastewater treatment, for example. Water treatment plants use a lot of energy and chemistry and have a lot of costs associated with processing and disposing of sludges. So what could we learn from nature about how to solve that problem? Well, we can look at wetlands, right? Like they're sometimes referred to as the kidneys of the earth because they're very good at filtering out impurities in water. And that's because there's many different organisms living together, interacting, drawing up those nutrients from the water. And this idea inspired the living machine, or eco-machine. Sometimes can be called either one. John taught ecological design, has developed a process for building chemical-free on-site wastewater treatment plants that essentially just recreate a wetland ecosystem in a controlled manner. And this is one here in New York State at the Omega Center, and it treats over 50,000 gallons of domestic wastewater every day without any chemicals. And the water's clean enough to just be discharged after that. So the point I'm starting to get at is that we share a lot of common challenges with our fellow earthlings, right? We have problems that we want to solve. There are examples in nature where organisms have had to learn to solve similar problems as well. And here's a story that I really like. So you might recognize this as a coral reef. Coral look like plants, but they're really little tiny animals, and they're all living in community. They build this complex structure. Here's a sort of smaller scale view. You can see they're these little, tender, fleshy, soft-bodied animals, but they build this exoskeleton out of calcium carbonate to live in. And if we get a little imaginative, it's kind of not hard to see how what they're doing is similar to sort of what we do. We build, large, hard, rock-like concrete structures to house ourselves, right, from the elements. So, but we're creating these structures in very, very different ways. But there is this match, this commonality in what we're trying to accomplish, right? Like on the left here, that's the skeleton of a coral. There aren't any living organisms in it anymore. And then, of course, concrete on the right. And the amazing thing is that these are both made out of calcium carbonate. They're the same basic material structure. But the way we make concrete to build our structures, we have cement, which is the binding agent, and that gets mixed with water and lots of rock aggregate. And then it originates, it comes from limestone deposits, which if you know some things about geology, you'll know that limestone is the ancient seabed, so it's really sort of the fossilized remains of marine organisms. And so this material is very rich in calcium carbonate. So we mine that to the tune of more than 39 billion tons per year. And then it has to get fired to very, very, very high temperatures, which makes a subtle change in its molecular structure so that it'll react with water and harden again. And then there's lots of energy inputs for packing and shipping and moving it around the country. And in the end, every ton of cement emits 1 ton of CO2. Which adds up to about the third largest man-made source of CO2 on the planet, 6% of global CO2 emissions. Meanwhile, the corals, by contrast, are building very similar calcium carbonate structures by capturing calcium dissolved in the seawater with carbon dioxide and assembling it on site in a very low energy process that has lasted for over 450 million years. Everything's built to shape on site. There's no shipping involved. It's taking this abundant material out of the ecosystem in its immediate environments and turning it into something useful. It's also a very multifunctional design. The coral reefs are regenerative systems, right? They provide many beneficial functions, supporting the base of the ecosystem of the oceans. It's a very important nursery ground for many fish species. They also provide important services in terms of protecting coastlines from storms and erosion. And it's an important economic benefit to people, too. There's $30 billion annually in direct economic benefit worldwide through the productivity of coral reefs in food, fisheries, and tourism. So one of these systems is building wealth, and the other is extracting a resource, right? So it's a pretty sobering comparison of the human technology versus what we could think of as nature's technology, which can be, kind of depressing. But on the other hand, I like to think of it as an inspiration to do better. There's an example out here of a system that works, which we can aspire to recreate and develop technologies that will allow us to do the same thing. Our co-founder, Janine Benyus, puts it this way, that natural organisms have managed to do everything we want to do without guzzling fossil fuels, polluting the planet, or mortgaging the future. Nature has, builds and makes materials, it breaks down materials, it creates structures, a lot of examples of energy conservation in nature. Staying clean, cooperating, coordinating. We can find analogs for a lot of things that we want to do if we look to the natural world with the right frame of mind. And nature strategies are designed to work in context, right? So the species that are around today are so because, they've come up with ways to get by that have lasted for generations within the specific ecological constraints of their place. So, the big question that biomimics are asking is, how can what we make fit in as elegantly as these other living systems around us? And if you squint, you can see there's an owl hiding in there. Our co-founder, Janine Benyus, which if you don't know her already, she's worth looking up. She has a couple really great TED Talks. She wrote a book called Biomimicry, Innovation Inspired by Nature, that sort of put the field on the map. It was previously something that was of interest to a few researchers in various labs that were looking at natural models to help design new technological innovations. And she became fascinated by that approach and kind of gave it a name and a presence in the popular media, which has only grown in the 20 years since the book first came out. And in her book, she describes biomimicry as looking to nature as a model. That is the example or prototype, a source of ideas for how we could do things differently. Also as a measure, meaning sort of the yardstick by which we decide whether something's good enough, right? Like, can our systems perform at the same level as natural systems? And then ultimately, as a mentor, that we should have a closer relationship with nature that really values it, not just for what we can take, but for what we can learn. And that, these ideas that we can gain from nature, are a rationale for making sure that we protect wild species and their habitats, and understand that, we are dependent on them. So I wanted to share a few more case studies that relate more specifically to the topic of climate change. In terms of energy systems, there are a few interesting innovations. I'm only going to touch on a small number here, but an interesting phenomenon in nature is that, as fish swim, they shed tiny vortices. It's the nature of the fluid flow around something passing through water. And when they swim in schools, they actually have a way of doing so where they're sort of surfing the vortices off each other, and it allows them to lower the energetic costs of swimming as a group. A researcher named John DeBerry has taken inspiration from this phenomena to develop a new approach to laying out wind energy arrays. So using vertical axis wind turbines in a formation similar to how fish school together, it can actually increase the efficiency of the whole array because the wind is actually hitting one turbine and then the next and the next and the next in a chain. Similarly, birds and social insects like bees will also fly together in swarms, and they're a great model of self-organization and decentralization of systems. So, they are coordinating their behaviors without some sort of top-down authority controlling them. There isn't a leader that's being followed. Each organism is following a set of simple rules that in aggregate creates this phenomenon of flocking and swarming. A company called NCycle they used to be called Regen, so I keep kind of tripping over that every now and then, has developed a device that applies this concept to how managing energy usage in buildings. So in especially large commercial buildings, there's a lot of mechanical equipment that cycles off and on, heating and cooling, ventilation, refrigeration, all that jazz. And if all that stuff is running at the same time, it creates a huge energy load for the building, which can be quite expensive because during the day, energy costs fluctuate over time, and it actually costs more to use energy during the day when everyone else wants it, right? And so there's in our energy grid, there are what are called peaker plants, which just come online during peak load, and they tend to be dirtier sources like coal. But if we could spread out the energy demand and avoid those peaks, it would be much more efficient and also cost effective for these building managers. So NCycle's strategy is to create a mesh wireless network of individual controllers on each of these appliances, which communicate with each other using an algorithm that helps them balance those loads so that things aren't operating simultaneously when they don't have to. Food systems are also a really important area, of course, when we're thinking about climate change. And I think one of the most inspiring examples of a sustainable food system is if you look at an ecosystem like a prairie. Prairies, plants, most of them are perennials. And in the soil, they have this huge network of dense roots and rhizomes. And even though the plant may die back in the winter, it springs back to life every spring from those roots. And this is a very beneficial phenomenon because those roots help nurture the soil microbiome, they help aerate the soil, they decompose and enrich the soil with organic matter. The existence of prairies, especially in North America, is one of the reasons why there is such fertile farmland in the Midwest. But our current farming practices are stripping that away because it's not renewing itself. So there's an organization in Kansas called the Land Institute, which is developing perennial agriculture. They're breeding new crops that will grow perennially. They planted once and they come back every year. And they're also designed to be grown and harvested in polycultures, meaning mixed groups of plants. It's not a monoculture of everything is corn or everything is soybeans. And that builds in resilience for the farmer. If there's a bad crop year, they've got two crops on the same land. One might be better able to survive, a weather-related impact related to climate change, or a pest incident or something. But also polycultures are very resilient because there's, when you have all of one thing, the insects can do a lot more damage. And if it's a lot of different things growing together, there's less for them to be attracted to, and the damage isn't so bad. So one of the most successful primary crops that the Land Institute has developed is a perennial wheat called Kernza, and the first commercial product that they produced with it was a beer made, brewed in Portland through a partnership with Patagonia Provisions, which Patagonia is getting into the food market, sustainable food market, which is a pretty interesting transition for them. But this is, I think, a really exciting area in biomimicry because we know that regenerative farming is something we absolutely need to control carbon emissions, and these plants have the ability to actually sequester carbon at the same time that they're producing food. So we could maybe think of this as sort of the equivalent of an underwater prairie. So we've got multi-polycultures on land. They're also, of course, in our oceans. So there's an outfit called Green Wave that is developing a similar marine ecosystem strategy for food production, where they're able to produce edible seaweeds and shellfish while sequestering carbon and rebuilding reef ecosystems. It turns out kelp is a very large consumer of CO2, so it has a lot of carbon sequestration potential there. Speaking of carbon sequestration, So I think this already came up in one of the talks earlier today, but you know, a precedent already exists for, you know, using CO2 as a resource, right? We think of it as a pollutant because its excess amounts are causing a lot of problems for us today, but in the plant world, this is food, right? So every plant is using CO2 as a building block to make its tissues. It's taking carbon dioxide out of the air, water from the ground, and using energy from the sun to make everything it needs to live. There's a company called Blue Planet that has looked at the corals strategy, which we talked about earlier, and is mimicking that to solve the carbon capture problem and to create substitute carbon sequestrating cement and also building materials like aggregates. So they estimate that they can sequester a half ton of CO2 permanently for every ton of CO2 that, or every ton of cement that they produce using this method. What they're doing basically is bubbling emissions, CO2 from power plants and other sources through a brine that mimics sort of the ocean seawater that's saturated with calcium, and then obviously the carbon dioxide is through a reaction precipitating out as calcium carbonate. And they're able to use that to make the building materials. And you know, I think this strategy of using how we build materials to actually begin to sequester carbon is going to be critically important because our populations are only growing. People are increasingly moving to cities, and you know, just in the 3 years, trying to use more cement than the U.S. did in the entire 21st century or 20th century, which I think is a good indicator of like the rapid pace of building that we're in and that is to come. And that's not just China, you know, that's in India, and like globally, populations are growing and more people are leaving rural areas and relocating to the cities, and building in cities is heavily focused on concrete. So I think innovations like Blue Planet are going to be really important. Similarly, there are companies out there now that are looking at converting waste greenhouse gas emissions from farming operations, water treatment plants, landfills, energy facilities, and turning it into plastic products. So New Light is a company that has developed a process to create bioplastics that can replace conventional plastics in most applications, which is really exciting. And they actually recently inked a deal with IKEA, which is going to begin using their plastics in 40% of their product line. So to zoom out for a minute, you know, if we're successful, you know, if we can develop the biomimetic solutions we need, like what's the next step, right? And I think, you know, for me, it means communities that function like ecosystems, right? Like what if our communities, our buildings, our towns and cities were as sustainable as an undisturbed, intact ecosystem on the basis of carbon storage, nutrient cycling, water capture and filtration, you know, capturing energy for daily use. I think this is sort of the big sort of moonshot of biomimicry. Like how can we start to create our world in the image of the natural world so that functionally, on the basis of ecosystem services provided, there's no difference. And there's an organization called the International Living Future Institute, which you might be interested in. They've developed the most rigorous performance standard for the building industry. They call it the Living Building Challenge. And the mandate is that the building be entirely self-sufficient, that it produce all the energy that it needs on site, all of the water that it needs on site, and that it have a net positive impact on, you know, human health and wellness in the community, as well as natural systems. The Bullitt Center in Seattle, Washington is an office building that was built and received Living Building certification. One of the things that's interesting about it, I didn't realize this until I looked in the case study, most commercial buildings are only designed to last about 40 years. You know, so all of that, those resources going into putting that building up, and they figure it's going to be obsolete. They need to be torn down or radically rehabbed in 40 years. This building is designed for a 250-year lifespan. And all of the materials that went into it were, you know, rigorously evaluated for their sustainability performance. It uses all certified sustainable timber, They have geothermal heating system. It's 6 stories tall and has compostable toilets, which apparently it's like one of the only installations of its kind that's been successful with that. They're still working on the certifications with the city, but their plan is to capture all of their water from rainwater. Seattle's rainy, so it's a little easier for them to do that there, and filter it on site for all of their domestic potable water usage. But the building and industry has to do a little bit of catching up in the regulatory environment for these kinds of radical new ideas. So, if we're gonna get to this point where we can build that, make that the standard, right, for all of our building, like how do we get there? Biomimicry needs to go mainstream. And that's why I'm talking to all of you and want to get you all excited to go out there and study or at least support biomimetic innovation. At the Biomimicry Institute, how we're doing it is sort of 2 key strategies. One is we run a website called Ask Nature. You can find it at asknature.org, which brings what we think of as biological intelligence sort of to your desktop. You can search, how does nature filter water? How does nature create resilient structures? You can search by function, a design or engineering function, and find examples of strategies for how organisms and ecosystems have evolved to serve a similar or the same function. And then we run a suite of design challenges that are aimed at educating the next generation of biomimicry innovators and supporting their forays into entrepreneurship. And I'll just talk a little bit about a couple of those. So asknature.org. You can see here, you can search by function. That's a quick search result for ventilation. And then you can also drill down into more specific functions according to a taxonomy that the site is built on. If you want to know a little bit more about all that, I can go into it later. But it's a pretty interesting way to think through the lens of function about a design challenge and see how nature has performed those same functions. There's also a catalog of inspired, biologically inspired design ideas, everything from concepts that are still in development to products on the market, and then a library of resources. And then our flagship design challenge is the Biomimicry Global Design Challenge. And this is a program designed for university students and young professionals. The focus is on developing bio-inspired solutions for climate change. So in partnership with the Ray C. Anderson Foundation, we've developed this program. It provides biomimicry training through online resources and then prizes for winning designs, which then get invited into our Biomimicry Launchpad program, which is the entrepreneurship side of the coin. It's the world's only accelerator program that is focused on bringing more nature-inspired climate change solutions to the market. One of the graduates, if you will, from that program are two design teams that have formed a partnership with, I think it's 27 other partners from 10 countries, and they went after a grant from the EU and got $10 million for a project focused on using biomimetic innovation to restore dry lands in the Greek islands. So 44% of global food production is on degrading soils in very arid regions, and that's especially true in the Mediterranean. And so this project brings together one of our Launchpad participants that developed a very low-cost, modular, efficient solar still inspired by mangroves to produce clean potable water or irrigation water from seawater. And then another team from the same year of the Launchpad program that developed a very water efficient composting and a greenhouse system. And they're working again with these other partners on this very large scale project to produce fresh water for agricultural and household uses through this multi-stage they call it like a water ecosystem. So it's something we're very excited about following. Saving forests is also a critical piece of the climate change puzzle. And our most recent cohort of the Biomimicry Launchpad, this team, Nucleario, won our $100,000 Ray of Hope Prize award for their innovation, which is focused on reforestation and afforestation, which is planting forests where there weren't previously forests. So instead of just reforesting where there were forests, also actually growing the total land area in forest in Brazil. I think it's close to 50% of Brazil's greenhouse gas emissions actually come from deforestation. And so they're focusing on the Atlantic rainforest, which is along the Atlantic coast of Brazil, and have developed an innovation that dramatically reduces the labor involved in replanting and reestablishing these forests. It was inspired by bromeliads and forest leaf litter, and it essentially kind of creates a nursery environment for seedlings that defends them against leafcutter ants and other pests and invasive species, so that these trees can get a head start without the costly inputs of like human monitoring and maintenance and fertilizer and pesticides. And what you're seeing in there is a plastic prototype that they've been testing, but the long-term goal is to have a fully biodegradable organic product. And sort of the last chapter in our design challenge programs is our brand new, recently introduced program for youth. So it's modeled on the university level challenge, but focused on high school and middle school. So it's something maybe some of you would be interested in. We work with teachers to provide curriculum and resources to support student teams, focusing on climate change solutions through the lens of biomimicry. And here are a couple teams from our inaugural pilot year. These middle school students were inspired by the Saharan silver ant and the desert scorpion and developed a solar reflective roofing tile. And then these high school students in South Carolina developed and tested a promising design for a solar concentrator based on the microstructure of the oriental hornet and how it reflects light to it. Actually, this organism, it's incredible. It actually has little mini like solar panels essentially in its body. It actually collects some amount of solar energy, electricity, to support its activities. So they were looking at the biology of that for their design. And so just to wrap up, what this is all about really is transitioning from looking at nature as an object or something to learn about to something that we can learn from, right? So, looking at the tree and not just maybe knowing its name, but, understanding that there's this really robust and fascinating system of functions and services that it's performing. And because it all starts with observation and seeing through this lens of function in nature, we are going to transition now to welcome our special guest and Leah, his handler, and do a little activity and exercise with you guys.
I tell my students that when we look at nature from a different perspective, and that's what biomimicry is inviting you to do, and looking at all of nature, even those creepy crawly critters that we all love to hate, think about that big ugly spider, instead of the first response being let's kill it, what can we learn from it? And spiders are so interesting. They can teach us so much. They can do with their webs. There's so many interesting things to learn. So now we're going to move to something even more interesting.
Yeah. So do you want to just introduce?
Yes. One second. Let me just secure him.
Oh, he's so beautiful.
Do you have a preference where I stand? Do you mind if I walk around?
Yeah, I think it would be great if you'd walk around. And
Okay. I'm going to scoop behind you. Good evening, everybody. Well, I'm going to hold this. My name is Leah. I am the curator here at the Wild Center, and yeah, go ahead. So here's food for thought, since he just showed us that. Birds don't have bladders. That is one way they stay light, so they just go to the bathroom when they have to go. and he will probably go again. This is Rowan. He is a red-tailed hawk. He's actually a juvenile, so as I spin him around, you'll notice he doesn't have his red tail yet. He will get that next year when he's an adult. So,
Very cool.
yeah.
So our exercise, so I talked a lot about the power of observation, and one thing that we do in our workshops
wander.
around biomimicry is we ask people to go out and sit in nature for like 20 to 30 minutes. Just sit somewhere quiet and just look. And you would be surprised after you get past like 5 to 10 minutes of sort of twiddling your thumbs and like going through your mental to-do list, and you're sort of really start to see what's around you. It's amazing what you begin to notice and the questions you start to form about, well, why is it like that? So I wanted to recreate an element of that experience with you today, because we have this really unique opportunity with the Wild Center to view an animal up close, which a lot of times when we go out and we do these nature observation exercises, you're mostly looking at plants or bugs, because it's kind of rare to get a larger animal passing through, or it's a lucky find. So it's a really unique opportunity for us to spend time looking and thinking about the red-tail hawk and why it is the way it is, right? And so what I want to ask you to do first, we'll walk through sort of a series of questions, is to look and tell me what do you notice about this animal? Like what stands out about its behavior, its physical features? Like what are some things that you notice?
Anyone want to call out? What do you notice about this?
I heard someone said it's sleek.
A sharp beak?
White belly and
What? Okay, the white underside and the dark brown top. Okay.
I also heard somebody say talons,
The
which if
talons?
you haven't heard that term before, those are those gigantic sharp curved claws that he's holding onto my glove with.
What about the feathers? Take a look closely at those feathers. Are they all the same? His tail feathers are longer? What else? The head can swivel really far? What else do you see? Anybody over here?
not relaxed. He's always moving.
For insulation and certain feathers that are for flying.
They're great.
Certain feathers for insulation, certain feathers for flying. Great.
You're getting to function. That's great. So,
Anybody else over here? Notice? Mhm. Anything about that beak?
Beak is also rounded, like curved.
putting up some other pictures for those of you in the back that maybe can't see them as well.
Yeah. How about looking at the eyes?
Ooh, there's a good one. I heard somebody mention his brow bone. That's called a supraorbital ridge. Some vocabulary terms for you tonight.
You can tell he has telescopic vision, so his eyes face forward versus being on the sides of his head.
Other observations? Even about its behavior, the way it's flying. Yeah.
He doesn't have a bladder, so he's lighter.
Very good.
All right. You guys are good at this. Since you guys, many of you are local, you might know something about where this animal lives, or maybe you could make guesses if you don't. Should we talk about maybe what kind of habitat? And, oh boy.
So I
Where would
noticed
you be
about
likely
the
to find
eyes.
this animal?
I think he just gave you a hint.
Yeah. Oh, yeah.
I was
Looking
going to
for-
mention about the eyes that although like ours, they're focused forward, they also focus to the side so that when he turns, unlike ours, which are more directed.
So there's a lot of range to the eyes. Is that? Oh,
I was going to say that there's maybe more of a lack of range because the eyes
Oh, that's okay.
don't move in the head. He just moves his head to see.
yeah, questions are good too.
Question was, what is he doing with his foot right now? Great question. So he has one foot tucked up. That is what a lot of birds will do when they're comfortable and they're resting.
Oh,
It's a resting pose.
so that's a good sign.
It is a good sign.
Relaxing a little bit.
Yeah, I think this is the largest crowd he's been around so far, so it's a good sign.
I was noticing that he seems to have different ways to propel himself through the air.
So what specific, is there a way you could describe maybe how?
Well,
Even if it's a guess is okay.
gliding, hunting.
So like gliding versus flapping.
Yeah,
Yeah.
and going in for a landing when prey is the goal, the
Yeah.
objective, and then one time it looked like he was looking, so he was head first, but another time talons first.
Yeah, in the photos.
These are great photos, by the way.
Oh,
I'm enjoying
thank
them.
you, Google.
I see them a lot on highways, and I'm thinking they hunt along edges between
That's a
different
great
habitats.
Absolutely. For those of you who travel the New York State Thruway, keep your eyes peeled while also still on the road, but you'll often see them sitting right on the side of the thruway.
Is there anything we haven't covered that you want to share in terms of physical?
Physical aperture. I think we've pretty much covered a lot of the topics already.
That's great. So now what I want to invite you to do is start to think about the functions that some of these attributes serve for the hawk. Like why or how do they use that attribute? How does that serve its long-term survival? What's the adaptive sort of benefit? For example, we could go through this list.
All right, so hunting at edges. Yes. So the small prey is along the edges?
The prey is more, or easier to see, maybe as easier to find.
Okay.
And typically edges between one habitat and the next are often a good place for a lot of different animals to live, so there's often a lot of different prey types in an edge. One of the preferred places for redtails to sit is often on a windbreak in a farm field, so where there's a line of trees that a farmer has planted in between crops, they'll sit right there and there's perfect opportunity to look for prey. Generally, redtails are eating small rodents up to things as large as snowshoe hare, so squirrels, mice, voles, all kinds of stuff. Occasionally chickens.
So that function is actually just to find food.
So what about some of these other?
Shark beak, the dark top, lighter bottom, long-tailed feathers, the head swivels. I don't know what that is.
Oh, this is a moving.
Moving and alert.
Moving and alert. Yeah.
Okay. Different types of feathers, the brow bones, forward eyes, no bladder, eyes don't move.
Well, yeah. So we had, Leah helped us identify this.
Then,
one.
yes.
Early no bladder, so this is light.
Light, okay. You know what, nobody mentioned the bones of the bird. I just realized. What about the hollow?
But we know they're there. It's okay to use prior knowledge in inferences.
Okay. So what would we say would be the function of that shark beak? Why is that beak so sharp? What's the purpose of it? Ripping. Okay. so
good.
to-
Rip and cut.
Rip and cut, yes.
Yeah.
How about those feathers? What's the purpose of the different types of feathers?
I thought I heard.
Mm-hmm.
Yeah, so there's different types of feathers on the body for different purposes, right?
Feathers also provide insulation. How many people own a down coat? Me.
Yeah.
They're some of the warmest material out there, and we've been using down for, I don't know, lots of years in our products.
Yeah, so in this photo, you can see the really fluffy little downy bits at the base of the feather.
And it's interesting, the wingtip feathers can actually move to create more aerodynamics. So if we're thinking about application for perhaps an airplane, could they create a wing that would be able to, the wings on an airplane could adjust so that maybe they would be able to be lighter, so we need less fuel to support the movement of the plane. It's that
Photos I
dark
have in here.
upper part, and there's those tail feathers.
What do you think the purpose of the red tail is? I mean, I realize Rowan doesn't have his yet, but does anyone have a guess? And then Leah can tell us if we're right.
I generally red tails, most of their feather coloration, believe it or not, is for camouflage. So even when they're sitting in a tree, if you're not really paying attention, you can walk right by them and not notice. So they're, all that mottled color is going to blend in with the bark of a tree. They're also lighter on their breasts, so when they're up above flying, the prey that's down below might not notice them. If they were a big dark shape, a little mouse certainly would notice them better. And the red tail often functions in breeding, so that signals a breeding adult.
Yeah, so it's a communication.
Visual
Well,
communication.
It would be really to protect, so the function of the different colors of the feathers would be to protect from above any predator that would attack them wouldn't be able to see them as well, and from below.
Do larger birds prey on them, or are they? pretty much-
Sure.
Yeah.
Birds of prey don't discriminate, so if they think they can take prey items, they will. I was actually just at a falconry field meet last weekend, and Rowan tried to go after a couple birds there. Luckily, he was on my fist at the time, and he couldn't go anywhere, but he was very interested in the birds, which included other red tails. Yeah.
Do larger birds of prey on the red tail?
Yes,
Yeah,
they
so
can.
Like an eagle or
Yep,
something?
an eagle would, for sure.
So the talon, what do we notice of the arrangement of the toes on the feet? Hunting and perching, and do you notice how they're
Helix. The helix is the back toe.
Yes, there.
Yeah.
You can talk about
Yeah.
it.
So in a red-tailed hawk, they have 3 toes forward and 1 toe back. That is for perching, but also that's the best grip when they're going to kill prey. So that imparts a lot of pressure. There's some physics involved there that I don't completely understand, but that's the best grip to be able to quickly dispatch their prey, because they actually can become injured by the prey that they're trying to make a meal out of. So, and they estimate red-tailed hawks have something between 200 to 300 pounds per square inch of pressure in their grip, which,
Amazing.
to put it in perspective, we might have about 10 pounds per square inch in our hands. So, very strong.
And where are those? So that there's not a lot of musculature in the feet itself. So how are they gripping?
There are, they have ratcheting tendons in their legs, so that's one way. All birds have that, so when they're perched and they're sleeping, they don't fall off branches. If you've ever wondered that before. But there's the way their tendons ratchet also imparts that strength as well.
So really the function then of the talons would be to attach and to capture.
Yes. Capture and kill
Yeah.
quickly.
Yeah, also to grasp very tightly, right? Very strongly. So now that, based on what we know, so we've talked about some functions and features, one of the critical sort of steps in biomimicry is thinking through this lens of function. Like, okay, what does this do in the living system, in the nature's context, and how might that relate to design problems that we have? And so, does anyone have some ideas? Even if they're kind of crazy ideas, that's fine. Like, what might we learn from looking and studying, the mechanism of some of these different strategies that the bird has to inform a new kind of design solution?
So I gave an example with the wingtip feathers and designing a plain wing. That would be an application.
I don't know, like skydiving or those suits they make whenever you can like jump off like a cliff and glide through the air or something.
Yeah, so another gliding strategy.
The claw could be used for winning in like claw machine game.
Ah, yeah, there you go.
The ratcheting tendon could be used as a structural element in various pieces of equipment.
Yeah, that's a great idea.
I've often wondered if we could somehow use that in buildings, especially in earthquake-prone situations.
Bad idea.
Other ideas?
No, we didn't. What function we didn't talk about? Sorry to digress. Just step back a bit. You mentioned the supraorbital bone.
Yeah. So that's what gives hawks and eagles that very fierce look. They have a very bony ridge, eyebrow ridge basically, and it helps cut glare so they can see well on sunny days.
Like built-in hat, kind of.
Absolutely, it's like a built-in baseball cap brim.
Do they have a nictitating membrane on their eyes?
They do. Yep.
That's a third eyelid that closes and helps to filter out and protect the eye.
There was another idea over there, I think.
Was there? Who had their hand up?
There.
Oh,
Also, I made a mistake when I said telescopic vision. It should have been binocular vision, so sorry about that. But also the counter shading and modeling pattern on the hawk could be used in advanced military situations with camouflage or ghillie type suits or any type of camouflage someone would need.
Awesome, great ideas. So I know we're a little bit over time. It's dinner time, so maybe if there's a couple more ideas folks want to throw out, we'd have time for that. And then, or if you have a question, I know I threw a lot at you and then we went right into this. So,
And I will also hang out after the program if you're not starving and you want to get a little closer to Rowan. You're welcome to do that.
and we also invite you to consider becoming part of the design challenge. It's an exciting way of beginning to look at solutions for climate change, but also to be creative and inventive and work as a team.
So, thank you so much to Gretchen and Dorna and Leah and Rowan for being here. We're so happy that